Ciao again. I'm still Valerio, and now I will try to make some demonstration about the LoRawan network. I don't know how I can show, but I have a presentation, so I will show all the parts. So the main idea is to transmit a Bitcoin transaction using the LoRaWAN protocol, and I want to say you more about. Okay. I want to say you more about LPWAN. So the low power wide area network is a type of wireless communication that it's interesting for wide area, allowing low range communication, but this is a bit not clear, because if you want a low power communication and wide area, sometimes it's not something that match. So the trick is that you can use low bandwidth, so you will have very interesting connection that can go very far from you with low power, but you will have very, very low bandwidth. It means that you cannot send a lot of information in a little amount of time. This kind of protocol are used in the Internet of Things in order to connect a device to the Internet, usually in a bidirectional way. So you send information and you want to receive also. But remember that a lot of time the device connected to IoT are maybe battery based, so they rarely are connected always on the Internet. So maybe they will connect on several time frames. So if we watch other communication standards like cellular, like Wi-Fi, like Bluetooth Low Energy, like Zigbee, or satellite also, we can create this table in which for these purposes the only bad side of LoRa and other protocol are the low bandwidth. So when you start to think about this solution, remember that you have low bandwidth. So LoRa, it's long range. It's not a very interesting acronym. Is a digital wireless communication technology that can work in different band, like every band is sub-gigahertz band, so 169, okay, not in every country with the same restriction, 433 worldwide, 868 in Europe, 915.20 in US. And it uses the chirp spread spectrum technology, that is a kind of modulation that allow you to send this information with very low power and in a kind of good way that you can easily reconstruct. These are some kind of chirp communication from a LoRa radio in the spectrum. So you will see this kind of lines. It's long range. It's very hard to say a range for a radio technology. Usually 10, 20 kilometers if you are in a good environment. Indoor, you will never reach this kind of distance. But it's low power, consume very low power, and consume only for the time that you send or when you decide to receive information. It's bidirectional, it's fully bidirectional. You can receive and send with almost the same speed rate. It's low cost and can support a mesh network, just the LoRa. The LoRa is the physical protocol. What is LoRaWAN? LoRaWAN is one possible network layer for LoRa. So on top of LoRa, you need something for encrypt your message, have some kind of addresses or other information. Allow asynchronous communication, but use gateway and application server. So usually on LoRa you have your device, some gateway that send information on some network server and on application server also. And when you want to receive the information, the network server will send the information to the right gateway. Use two kind of encryption. One for the network. I mean, it's a key, network key that that the network know, and one for the application that just the developer of the application know. Using LoRaWAN protocol, the Things Network is a project that want to create a worldwide network for the Internet of Things based on LoRaWAN. It's collaborative, so it's free, and you can connect some gateway on the Things Network, and it's very active, very used in makers community. So a lot of people connect the gateway on the Things Network. Actually, there are around 6,000 gateway up and running in the world, and 2 in Malta. But it's provided by makers, so you are never be sure that that gateway are active and working when you need. So about the hardware, if you want some node that allow you to develop some protocol with LoRa on LoRaWAN, you can buy one of these 2 nodes based on SP32 core. SP32 core is a dual core 32-bit microprocessor and supports secure boot and flash encryption. You have just to write your firmware and has 3 radio. The Bluetooth low energy, the Wi-Fi, and the LoRa. And the cost is $10. If you need the gateway, you can buy this one. It's use almost the same components like a node. Has open source firmware for the Things Network, but allow only 1 channel, so it's not fully compliant with LoRaWAN, but working well and cost only $20. So I will use this. The main problem was that there is no a simple way to send messages on LoRaWAN, so I decided to create a firmware, and I call it LoRaCaster, that allow to send some messages with this cheap board. So it's open source, is based on some standard lib. It's a multi-device. You can it works on different board, and when you attach to your computer, provide this simple line command interface that allow you to modify the radio and send messages using the LoRa radio. And if you want to send a big payload, automatically split this payload in chunks, in pieces. And it's open source, you can download from GitHub. The idea is that I have some payload, like a transaction, but I can send a file also. In the memory, I can upload this payload in the memory of my board, and I will need to split in messages. So because the LoRaWAN protocol has a maximum size for frame. So I propose this kind of stupid protocol that split one big transaction in a lot of messages that has a kind of a magic number, separator, package ID, so I can recognize different boards that send same message in the same time, another separator, and some counter, like total message counter and the number of this message, plus the payload of my transaction. How I can use it with LoRaCaster? It's very simple. I just need to connect to LoRaCaster. I need to copy the transaction or my file in the memory of the device. Actually, I can store only 90 kilobytes, so it's not enough, but I'm working for allow 100 kilobytes space in the device. And how I can upload my transaction? It's very simple. I have to write D plus my transaction in X and plus another character that sign that this is the end. And when I want to start, I just need to press capital S. The board automatically will split the message in chunks, in little pieces, and broadcast, following the LoRaWAN requirement that actually is 0.1% transmitting time. So a lot of time I cannot transmit if I want to follow the LoRaWAN requirements. If you want to try, I have another script that can receive. So and this one is based on the internet. So I directly connect to LoRaWAN application server, and I receive all messages, and I put in the same transaction. I merge the messages, and I check it and broadcast it through my node. And if you want to try on testnet, you can use this encryption key and device address and broadcast using this information. I have a script that will check for this key, and if I find messages, I will create the transaction and broadcast for you. So I will try to make a demo. Or maybe I can show here before. The idea is to call the Bitcoin key for create a raw transaction, fund it with some fund, sign it, and I will have this big payload, and I will load on my device and just press S. So after, I need only to wait that the board will send the message, and yeah.
Of course, this is intentional to demonstrate the problems of EISP unreliability.
Okay. Oh, yeah, but I have to connect other devices, so. So if you follow this link, and you can see that I have a web page that shows this transaction that was received by my server and broadcast to Bitcoin. If you create this with and you can create multiple of this script, so you can have some script that run in different countries, and one of these script will broadcast the transaction in the internet. So next step, I will need to refactor the code. I made this just for testing, but it's interesting because I want to add some kind of mesh network to this module, also with LoRa, with Wi-Fi, and with Bluetooth, and add some Bluetooth and Wi-Fi interface, so you can connect directly with your mobile phone. And another interesting idea is to use the same device to broadcast Bitcoin headers. So if I have some board that it's connecting every 10 minutes or half an hour or so, every hour, I can receive, when I connect and send my message, I can receive the past Bitcoin headers, so I can use for different purposes also. So I can show how I can receive messages on LoRaWAN. So I think if there is no working internet, but I have to restart a lot of things. Yeah, but I have to configure all interfaces. Okay, this is the end. So.
So when you're creating the transaction, you need to have the UTXO. So I'm assuming that in the setup, you would like keep a Bitcoin Core full node running and synced, and then if the internet goes down, well, you already have the UTXOs. But let's say that you receive money like after it, like you're offline. Would there be a way to like ask for the UTXOs somehow using LoRa? Is that something you've thought about, or?
No, I mean, you have very low bandwidth, so you cannot ask for every block or for a lot of information. And if you ask for too much specific information, you will lose your privacy. So you have this UTXO, you create offline your transaction, and you try to broadcast offline also.
What you could do is combine satellite and this, so that you're offline, but keep having, you know, coming blocks and mempool and whatnot, and then use this just to spend.